ओके सो प्यारे दोस्तों, कैसे हो आप सब लोग। आज के सेशन में हम लोग पढ़ाई करने वाले हैं हेलोफॉर्म रिएक्शन, जो स्पेसिफिकली होता है अल्फा मिथाइल कीटोन के लिए। अल्फा मिथाइल कीटोन के लिए ये रिएक्शन होता है। अब आप ध्यान से देखो, बहुत ध्यान से देखो, एग्जैक्टली ये रिएक्शन में होता क्या है। सही है, आपको एक दिया जाएगा कीटोन जो होगा अल्फा मिथाइल कीटोन। तो ये हो गया प्यारे दोस्तों अल्फा मिथाइल कीटोन। ये अल्फा मिथाइल कीटोन जो होता है वो हेलोफॉर्म रिएक्शन पॉजिटिव देता है। अब ये एग्जैक्टली हेलोफॉर्म रिएक्शन क्या होता है ना, वो देखना है। अब हेलोफॉर्म किसे बोला जाता है? CHCl3 को बोला जाता है क्लोरोफॉर्म। CHBr3 को बोला जाता है ब्रोमोफॉर्म एंड CHI3 को बोला जाता है आयोडोफॉर्म। इन तीनों में ना बच्चों एक चीज आपको ध्यान रखनी है, इन तीनों में आयोडोफॉर्म जो होता है वो ही सिर्फ येलो पीपीटी देता है। इसमें जो आयोडोफॉर्म होगा ना वही सिर्फ आपको येलो पीपीटी देगा। देखो करना कुछ नहीं है, बहुत आसान है। मैं इसको थोड़ा अलग तरीके से आपको लिख के देखेंगे। बेसिकली अल्फा मिथाइल कीटोन के लिए हेलोफॉर्म रिएक्शन जो होता है वो पॉजिटिव आता है। तो अल्फा मिथाइल कीटोन क्या होता है? ये हुआ हमारा अल्फा मिथाइल कीटोन। क्लियर? करना कुछ नहीं है, यहां पर एक हाइड्रोजन को सेपरेटली बता रहा हूं। ये होगा एसिडिक हाइड्रोजन, ये होगा एसिडिक हाइड्रोजन। ओके, अब आपको करना क्या है, आप लाओ एक NaOH। एक NaOH आपको क्या देगा? आपको देगा एक OH माइनस। ये एक OH माइनस जाएगा हाइड्रोजन को पकड़ के लाएगा, तो वो बन गया माइनस H2O। आपको हंसना नहीं है भैया, ध्यान से देखो यहाँ पर। ये आपको देगा एक H2O, तो H2O निकल गया। ओके, अब देखो H2O निकल गया ना, तो RC डबल बॉन्ड O, यहाँ पर आएगा CH2, यहाँ पर आएगा H चला गया प्लस के फॉर्मेट में माइनस। क्लियर? अब आपके पास क्या बचा है? आपके पास बचा है अभी Na+, वो कहीं पर भी यूटिलाइज नहीं हुआ। अब देखो, अब आपको क्या करना है, आप लाओ आयोडीन का 2 मॉलिक्यूल। क्यों आयोडीन का मॉलिक्यूल? मैंने आपको बताया क्योंकि आयोडोफॉर्म ही येलो पीपीटी देगा, बाकी में कोई कलर चेंज नहीं आता। हमें रिएक्शन हुआ कि नहीं हुआ वो मालूम नहीं पड़ पाएगा। क्लियर? अब आयोडीन का मॉलिक्यूल लेके आओ। आयोडीन का मॉलिक्यूल जब नजदीक आएगा तो पोलराइजेशन क्रिएट होगा, यहाँ पर प्लस डेल्टा, यहाँ पर माइनस डेल्टा। या आयोडीन इसके साथ बॉन्ड बनाएगा। अब देखो कैसा बॉन्ड बना, RC डबल बॉन्ड O, यहाँ पर CH2I। मैंने जैसे बताया था कि अभी भी उसके पास 2 एसिडिक हाइड्रोजन प्रेजेंट है। तो करना क्या है? करना कुछ नहीं है, इसे 2 मत लिखो, एक सिंगल हाइड्रोजन सेपरेट बताओ। सही है। अब फिर से एक बार NaOH लेके आओ, फिर से एक बार NaOH लेके आओगे तो ये आपको देगा OH माइनस का आयन। अब देखो यहाँ पर जैसे मैंने बताया था कि Na+ प्रेजेंट था, I था, तो एक NaI निकल जाएगा। क्लियर है? क्या निकल जाएगा? एक NaI निकल जाएगा। सही है। ओके, अब ये OH माइनस जो था ना वो जाएगा एसिडिक हाइड्रोजन को पकड़ के लाएगा। अब फिर से आपके पास यहाँ पर प्रिपेयर होगा RC डबल बॉन्ड O, यहाँ पर आएगा CH, बाजू में एक I था। ओके, यहाँ पर आया नेगेटिव चार्ज, जो H+ चला गया मतलब माइनस H2O। H+ चला गया मतलब माइनस H2O। बहुत बढ़िया। अब ध्यान से देखो, फिर से एक बार NaOH के साथ रिएक्शन करवाओ। क्यों NaOH के साथ रिएक्शन करवाओ? क्योंकि एक और एसिडिक हाइड्रोजन अभी भी प्रेजेंट है। तो करवाया जब रिएक्शन तो OH माइनस आपको देगा वो, एंड ये OH माइनस, हाँ यहाँ पर एक स्टेप बाकी रहता है। आपको करना है क्या, आप आयोडीन लेके आओ। जब आयोडीन लेके आओगे तो एक आयोडीन यहाँ पर चला जाएगा एंड आपको यहाँ पर मिलेगा RC डबल बॉन्ड पे O, यहाँ पर आएगा CHI2। एक आयोडीन गया, एक सोडियम गया, माइनस Na। क्लियर? अब आप क्या करोगे, फिर से एक बार NaOH लेके आओ। ये आपको देगा OH माइनस का है। ये OH माइनस को एसिडिक हाइड्रोजन के साथ रिएक्शन लगवा के लो तो वो आपको क्रिएट करके देगा कुछ RC डबल बॉन्ड O, यहां पर आएगा CI2 माइनस। फिर से आयोडीन को लेके आओ, आयोडीन इसके अंदर चला जाएगा एंड यहां पर प्रिपेयर होगा RC डबल बॉन्ड O CI3। सही है, एक आयोडीन बचा, एक सोडियम बचा, माइनस NaI। ओके, अब देखो यहां पर बहुत ज्यादा बच्चे ना वो गलतियां करते हैं। क्या गलती करते हैं कि अब आगे कैसे रिएक्शन होगा, तो वहां पर एक डिफिकल्टी क्रिएट होता है। देखो ध्यान से, जो CI3 है ना उसका माइनस आई इफेक्ट सबसे ज्यादा है। अगर माइनस आई इफेक्ट सबसे ज्यादा आएगा तो पोलैरिटी पे प्लस इस कार्बन पे सबसे ज्यादा क्रिएट होगा, वो याद रखो। इसकी वजह से आप क्या करो, फिर से एक बार NaOH लेके आओ, फिर से एक बार अगर NaOH लेके आ गए तो ये आपको OH माइनस देगा। अब ये वाला OH माइनस जाके कार्बोनिल कार्बन को टारगेट करेगा। अगर उसने कार्बोनिल कार्बन को टारगेट कर दिया तो देखो आपके पास क्या प्रिपेयर होगा, एक आएगा R, एक आएगा C, एक पे डबल बॉन्ड पे ऑक्सीजन, यहां पे आएगा OH एंड ये लीव हो जाएगा। माइनस आई की वजह से ये लीव हो गया CI3 माइनस, ये लीव हो गया। अब आप जैसे जानते हो कि ये जो क्रिएट हुआ ये तो एसिड है एंड एसिड का नेचर होता है प्रोटॉन डोनेट करना। अब इसने ये प्रोटॉन डोनेट कर दिया इसको, क्लियर? तो आपके पास क्या प्रिपेयर हो जाएगा CHI3, जिसे बोला जाता है आयोडोफॉर्म। आयोडोफॉर्म जो होता है उसका प्रॉपर्टी एंटीसेप्टिक प्रॉपर्टी होता है। उसका एंटीसेप्टिक प्रॉपर्टी होने का जो रीजन है वो होगा आयोडीन का लिबरेशन। आयोडीन लिबरेट होने की वजह से CHI3 का एक एंटीसेप्टिक प्रॉपर्टी निकल के आता है। आपके पास क्या क्रिएट हुआ, तो आपके पास क्रिएट हुआ RC डबल बॉन्ड पे O पे माइनस, क्लियर? ये जो एसिटेट एनायन बनके निकल के आया, अब ये एसिटेट एनायन एक जो सोडियम बचा होगा उसके साथ जाके आपको सॉल्ट देगा। तो आप ध्यान से देखो आपने टोटल कितने मॉलिक्यूल NaOH के कंज्यूम किए, तो 4 मॉलिक्यूल NaOH के कंज्यूम किए होंगे, 3 मॉलिक्यूल आपने H2 के कंज्यूम किए होंगे। X यहां पर ब्रोमीन हो सकता था, क्लोरीन हो सकता था, आयोडीन हो सकता था। अगर आपने आयोडीन लिया तो वो आयोडोफॉर्म टेस्ट कहलाएगा, अगर आपने क्लोरीन लिया तो वो क्लोरोफॉर्म टेस्ट कहलाएगा, अगर आपने ब्रोमीन लिया तो वो ब्रोमोफॉर्म टेस्ट कहलाएगा। पर बेसिकली याद रखना है ये दोनों में कोई कलर चेंज नहीं मिलता, इसी वजह से हम लोग कौन सा टेस्ट इसे प्रेफर करते हैं, आयोडोफॉर्म टेस्ट, दैट्स इट। अब लास्ट दो चीज वो याद रखना है कि जो एसिटिक एसिड होता है CH3C डबल बॉन्ड OH, कई बार एग्जाम में पूछा जाता है कि एसिटिक एसिड आपको आयोडोफॉर्म टेस्ट या फिर हेलोफॉर्म टेस्ट देगा, तो वो ध्यान रखिए ये आपको आयोडोफॉर्म टेस्ट नहीं दे पाएगा, क्योंकि यहाँ पर डायरेक्टली जो एसिडिक हाइड्रोजन है वो ये वाला होगा, यहां से नहीं होगा, क्लियर? दूसरी एक चीज याद रखो, अगर आपको पूछा जाता है कि CH3CH2OH क्या ये आपको आयोडोफॉर्म टेस्ट पॉजिटिव देगा, तो याद रखिए इथेनॉल आयोडोफॉर्म टेस्ट पॉजिटिव देता है, क्योंकि इथेनॉल जब ऑक्सीडाइज होगा, ऑक्सीडाइज होने के बाद वो आपको कीटोन मतलब अल्फा मिथाइल कीटोन में कन्वर्ट हो जाएगा, उसकी वजह से ये वाला आपको पॉजिटिव आयोडोफॉर्म टेस्ट देगा। तो इसके साथ आज का हेलोफॉर्म रिएक्शन वाला सेशन यहीं पर भी कंप्लीट हो रहा है। अब आपको करना कुछ नहीं है, घर पे जाके इसका रेगुलर से नोट बनाओ, वीडियो को एक बार रिवाइज कर देना एंड डोंट फॉरगेट टू लाइक शेयर एंड सब्सक्राइब द चैनल। थैंक यू फॉर वाचिंग दिस वीडियो।
In this video I take a look at the use of the iodoform test for particular types of alcohol. I'm using 2 molar sodium hydroxide solution, which I have in the left hand boiling tube there, together with a 10% solution of iodine made up in potassium iodide solution. In the second test tube I have ethanol. In the next test tube I have propan-1-ol. And next to that I have a position isomer of propan-1-ol, propan-2-ol, and then in the next test tube butan-1-ol. And you'll see there that I also have a hot water bath. Let's consider what kinds of alcohols give a positive iodoform reaction. To give a positive iodoform reaction, we have to have a molecule that has a carbon attached to an OH and to both a methyl group and a hydrogen atom. The other group represented by or can be pretty much any other grouping. But the carbon attached to the functional group of the alcohol must have both a methyl group and a hydrogen atom attached. You'll see the requirement of the hydrogen is so that it can undergo oxidation in this first phase of the reaction. And the methyl group, the CH3 group there, its requirement will become clear in that that's the group that ends up forming iodoform, properly known as triiodomethane. Now, in the first step of this iodoform test, which uses iodine solution and sodium hydroxide, this is what happens. First of all, you'll be probably familiar with this reaction at the bottom here, the reaction between chlorine and a cold dilute solution of sodium hydroxide. It forms sodium chlorate 1, also known as sodium hypochlorite, which is an oxidizing agent and is the active ingredient in bleaches. Well, this is the reaction just above it here that is relevant in this instance, but you can see it's similar. Instead of chlorine, we have the halogen iodine. The chemical reaction then is very similar, and here we get sodium iodate 1. That's to say the oxidation number or state of the iodine is +1. Now, if that oxidation number can be reduced, and of course it can be reduced, for example, to 0 in the element or to -1 in the iodide ion, then it's capable of being reduced and therefore can behave as an oxidizing agent. And that's what goes on here in the first step of the iodoform reaction for alcohols. Iodine and sodium hydroxide then react as shown in the equation below there to form sodium iodate 1. And it oxidizes that alcohol as follows. You can see that it has removed the H, hence the requirement for the H attached to that carbon holding the functional group. It introduces then a double bond O. So it's effectively removed two H's, the H that was attached to the carbon directly and the H of the functional group OH. So we've converted the alcohol in the first step to a carbonyl. The R group there could be H, which would mean that we would have an aldehyde, but if it's a carbon-bearing group, then it would be a ketone that we get there. In the next step, the iodine then reacts with the methyl group. Hence, as I said, the requirement for the methyl group, forming Ci3. So the H's have been replaced by iodines. Then in the final step, brought about by hydroxide ions from the sodium hydroxide, we get that organic compound there splitting, and it will produce the sodium salt of an acid together with CHI3, triiodomethane, also known simply as iodoform, and you'll see that it is a pale yellow solid with an antiseptic smell. And there's the other product of that reaction. You can see it's the sodium salt of a carboxylic acid there. But the key thing is it produces iodoform, which is a pale yellow solid with an antiseptic smell. If we have an alcohol with that particular type of grouping, that's to say where we have a carbon that's attached to an OH and is additionally attached to both a methyl group and a hydrogen atom. So let's get the tests underway so that you can see what happens and where the test is positive and negative. So I'm going to begin with the ethanol, as you can see, and I'll take some in a second boiling tube. Normally we just take 1 or 2 cubic centimeters of the alcohol in a test tube, but for the purpose of this demonstration video I've taken a much larger volume. Now you add approximately 1.5 times as much of the 10% the 10% iodine dissolved in potassium iodide. So I'm going to more than double the volume in the boiling tube there. If I was doing it in a test tube, I'd take probably about a cubic centimeter of the alcohol and add several drops of the 10% iodine solution. Okay, the test will not get underway, as you saw from the equations a moment ago, until I add the sodium hydroxide. So let's do that. I'm going to add 2 molar sodium hydroxide, and recall how that reacts with the iodine to produce sodium iodate 1, NaIO, which behaves as an oxidizing agent. And that will oxidize the alcohol to the corresponding carbonyl compound. And what the procedure requires me to do here is to add the 2 molar aqueous sodium hydroxide in a slow dropwise fashion. I'm using a small syringe here for convenience. And I keep adding the sodium hydroxide until the brown color of the iodine disappears, or just disappears. So I'm going to add the sodium hydroxide and shake it. And you're aware then that the sodium hydroxide will react with the iodine, and from that reaction we'll create or produce sodium iodate 1, NaIO, which is a mild oxidizing agent. You can see the color fading there as the sodium hydroxide goes in. And the question is it simply going to fade and produce a colorless solution, which would be a negative test? Or is it going to get lighter and brown and actually then produce a yellow precipitate triiodomethane that has an antiseptic smell? So let's see. So the brown color is fading as I continue to add the sodium hydroxide. So we're looking for one of two results. It is either going to go colorless and clear, or it's going to jump over to a yellow color and go cloudy as a fine yellow precipitate forms. And you can see what we've got here is a fine yellow precipitate. This is a positive test because we have produced triiodomethane. In there is a fine yellow precipitate, which you'll see at the end of the video when I filter it using vacuum filtration. So ethanol, which we would have expected from its structure, gives a positive iodoform test. In ethanol, you can see here we have a carbon that is bonded to an OH group and to a H and a methyl group. Those are the requirements for a positive iodoform reaction. So let's move on to the next alcohol, which is propan-1-ol. Consider the structure of propan-1-ol and whether or not you think it will give a positive iodoform reaction. So again, I'll take some propan-1-ol in a separate boiling tube. Much greater volume than one would use normally for these tests, just so that it shows up better on the camera. I'm going to add about 1.5 times as much of 10% iodine solution, dissolved potassium iodide. Note that iodine doesn't actually dissolve in water, but it dissolves in a dilute aqueous solution of potassium iodide. It actually goes into solution as the I3- ion, from which I2 can be liberated very quickly. Anyway, next I add the 2 molar aqueous sodium hydroxide. Again, I keep adding it with shaking until the brown color just disappears, and we're looking for one of two possible outcomes. It's either going to fade and fade and fade and eventually form a colorless clear solution like water, or it's going to jump over to a yellow color and become cloudy as a yellow precipitate forms inside, and that precipitate will have an antiseptic smell. Still a little bit brown, but watch what happens when it goes into the boiling water. You can already see there, I hope, that it's gone colourless and clear. That's a negative test. So with propane 1-ol, we have a negative result for the iodoform reaction. So we'd need to take a look at the structure again of propane 1-ol to see why we have a negative result. It must be the case that the carbon holding the OH group must have absent either the methyl group and or the hydrogen atom attached to it. So here's propane 1-ol. There's the key carbon in question that's attached to the OH. Well, it is indeed attached to a H, but you'll see it's not attached to CH3. It had an ethyl group instead of a methyl group, so that was the correct result, negative. Let's move on to the position isomer of propane 1-ol. That's propane 2-ol. So the position of the OH group on the 3-carbon chain is different. It's on the middle carbon rather than the outside carbon. So again, I've added my 10% iodine solution, and now I begin to add slowly with shaking the 2 molar sodium hydroxide solution. The brown color is fading, and we're looking for again one of two possible outcomes. And you can see already there that it's jumped over to that yellow color, yellow and cloudy, because we formed triiodomethane, known as iodoform. Pale yellow precipitate. I'm wafting the fumes towards my nose there, picking up the antiseptic smell. So why does propane 2-ol give a positive test? Let's look at the structure of propane 2-ol. There's it there. The OH is on the inside carbon. And does that inside carbon have attached to it both a H and a methyl group? Well, there's the H. And in fact, it has a methyl group either side. So you can see why it gave a positive iodoform reaction. Remember how the H there is removed in the oxidation reaction together with the H of the hydroxyl group. That happens during the oxidation stage. And then the H's of the methyl group are replaced with I's to give Ci3. And then it decomposes with the hydroxide ions in the final step to create triiodomethane together with the sodium salt of a carboxylic acid. So here I've got the last one, butane 1-ol. Consider its structure and whether you expect this test to be positive or negative. So I've added about 1.5 times as much 10% iodine solution as alcohol, and I'm now adding 2 molar sodium hydroxide solution slowly with shaking. The butane 2-ol is a bit more viscous and takes a bit more shaking here. The colour is fading. Did need a bit more encouragement this to see whether it was going to turn into a colourless solution or instead produce a yellow precipitate. So keep watching here. The colour is fading. I did feel the need to use the hot water bath in this instance to encourage it. Still not completely clear whether it's going yellow or brown at this stage, but watch it as it sits now in the hot water bath. And I did add a good bit more sodium hydroxide to get a result. I needed either it to go colourless and clear, or I needed it to go yellow and cloudy. I wanted one or other result, so I kept adding sodium hydroxide and warming it in the water bath. In fact, I found I had to add even more sodium hydroxide to get one result or other. And at this stage I was convinced that it wasn't the yellow precipitate. Certainly no yellow precipitate there. And at the bottom you can see it has gone colourless and clear. Here's the structure of butane 1-ol. There's the carbon that's attached to the OH. You can see that it does have a H attached, but it doesn't have a methyl group. It has a propyl group instead, and that won't do. So that's why it was negative, exactly what one would have expected. So that's the ethanol. We had a positive test with that, and we had a positive test with a propane 2-ol there. We had a negative test with a propane 1-ol. and we had a negative test with the butane 1-ol. Let's take a look then finally at the precipitate. So here's a Buchner funnel and Buchner flask attached to a siphon pump which draws the air out of the flask. This is referred to as vacuum filtration or filtering under reduced pressure. Into the Buchner funnel I need to place a filter paper of an appropriate size to cover the holes. And before I pour the suspension in, I do need to wet the filter paper to make it stick down over the holes, otherwise the precipitate will go underneath and I don't want that. So it's wetted down now with the solvent, and we can now pour it in. You can see I haven't made a great job of there's still some solid left behind, some of the triiodomethane left behind there. Pour this other one in as well. You can see actually the solid there has precipitated to the bottom. That's the triiodomethane, pale yellow solid with an antiseptic smell. Pour this in as well, just to be able to show you what the solid looks like. And there's it there on the filter paper. You may be required to describe a practice in which you purify that solid, and it would be purified by recrystallization from the minimum volume of hot ethanol, of course. That's my look at the iodoform tests. Thanks for listening.